Now in this lesson we're going to take a look at the converse of the Pythagorean theorem. If we think back to the actual Pythagorean theorem, it basically said if you have a right triangle, then a squared plus b squared equal to c squared is going to work in it. Kind of the nuts and bolts of it. Now, if we look at the converse, well now I'm going to start with, well if I know that a squared plus b squared equal to c squared is satisfied, meaning if I have numbers for a, b, and c that will make this equation true, well then those three numbers are going to make a right triangle, where the largest number will be c, which is the hypotenuse, and my two smaller numbers will be the a and b. If you want the actual words in it, I have that right here, word for word, for the Pythagorean theorem, or excuse me, the converse of the Pythagorean theorem. Now I'm going to take a look at one example to show you how we can use this. So it says, do the following side lengths make a right triangle? And I've given you three side lengths of a right triangle. Is it a right triangle, or is it just any old regular triangle? Well, I'm going to plug these three numbers into a squared plus b squared equal to c squared. Now it's very important that you make sure that you put the largest number in for c. So in this case it's 35. Sometimes we'll get confused because we'll just go through and we'll say a, b, c just because it's that order. But remember, the largest number always has to be the hypotenuse. And then the other two, it doesn't really matter. I usually like to put them in a numerical order, so I'm going to put 21 in for A, I'm going to put 28 in for B, and then really this is what we're doing. Oops, I forgot the squared here on my C, but now this is really what we're doing. We're trying to figure out, is it really equal? It's a question mark right now. I don't know if they're equal. I'm going to go through and I'm going to figure it out. So I'm going to use my calculator. I'm just going to hit, well, 21 squared. That comes out to be 441. If I take 28 and square that one, I get 784. And now I need to add those two numbers together, and I end up with 1,225. Now the question is 35 squared really 1,225? I hit it on my calculator, I find out that 35 squared is 1,225. These two things are equal, which means those three numbers, 21, 35, and 28, do make a right triangle. So to answer my question, do they make a right triangle? The answer is yes. Now just say, for some reason, this would have come out to be 1,224. Then these two things are not equal, and the answer to my question would have been no. But they were equal, so my three side lengths will make a right triangle. And that's going to conclude the converse of the Pythagorean theorem.